Okay, so we are looking at yesterday we looked at finding measures of center and spread. And the class before that we were looking at organizing data using these frequency tables. So we're going to kind of combine that today. And we're going to stick, of course, the categorical data doing the center and spread doesn't have much meaning. So we're going to look at numerical data in a frequency table. Now we said there's two types of numerical data, and that changes how the frequency table is going to look. We have discrete, you remember, which is data that can be counted. So it appears the numbers 0, 1, 2, 3, and on up. And then we have continuous, which are values that can be measured. So that has to be divided into ranges because you can't list each individual value. So we might have like 0 through 9, and 10 through 19, 20 through 29, and so on for ranges in those frequency tables. So of course we'd have the numbers, then you'd have the frequency over here. Now it is perfectly doable to find the mean or an approximate mean, and then the range in which the median falls, and again a range that is in the mode for a grouped frequency table for continuous data like this one. But it's a little bit longer process, and again they're all approximate. I'll see if I can spell. And the reason they're approximate is because this doesn't list individual values, it lists ranges. So we're working with the ranges of values instead of individual values. So when you work with that continuous frequency table, you have to find the midpoint of each range and use that to approximate it. So we're not going to do that as part of this course. What we're going to focus on using the discrete data frequency table and finding mean, median, mode, standard deviation for those. So I'm just going to give you an example. Let's look at number of classes being taken. Now, of course, some of our frequency tables have included 0. This one will not, because if you're taking 0 classes, you're technically not a student. So this one will start at 1, 2, 3, 4, and 5. And let's claim that nobody in our study takes more than 5 classes. Let's look at our frequency. The number of students who are taking 1 class in our group, let's say that is only 7. 2 classes is 12. 3 classes, 41. 5 classes, or 4 classes, let's say that is 38. And where does that end up with us? Well, I'm going to cut that down a little bit. Let's say this is 31, and then for 5 classes, let's say there's only 9 students taking 5 classes. So what we want to do now is we want to find, first, we're going to find the mean. The mean is going to require us to add a column to this table. And that column is going to be the number times the frequency. And why are we going to do that? Well, because the first step in finding the mean is to add them up, to sum the numbers. Well, to sum them up, you have to add each individual value up. To do that with group data, there's 7 ones. So 1 times 7 gives us 7. If you added those all up, you'd have a total of 7. There are 2 12s here. So 2 times 12 is 24. If you add, or sorry, there's 12 2s, I should say. So 2 times 12 is 24. So if you add up all 12 of those 2s, you get 24. There's 41 3s. So 3 times 41 is 123. If you add up all those 3s, you have 123. 31 4s. So 4 times 31 is 124. Again, if you add up all the 4s, 31 4s, you get 124. And there's 9 5s. So 5 times 9 is 45. Again, adding up 9 5s gives you 45. So that is step 1 of finding the mean, is to multiply the number, each value, times its frequency. Step 2 to find the mean, we're going to actually sum both of these columns. We're going to sum the frequency. If I add those up, we've got 19, 60, 91, and 100, which is good because that's what I was planning for. You're also going to sum this column. That's our value times its frequency here. So we've got 7 plus 24 is 31, 154, 278, 283, 323, it looks like is what I'm getting there. Yep, that looks like it's coming out, 323. So then step 3, the final step to find our mean. This right here, remember the mean is the sum over n. Well, this right here is our sum, the 323. That's the sum of our values. This sum here of our frequencies is n. That's how many items are in this list. So 323 divided by 100 is 3.23. So that is saying that the mean number of classes taken by a student is 3.23 classes this semester. So there's our mean. Not too different from what we did for individual values, only we were able, rather than having to add up 100 individual values here, we were able to do them in groups because there was repeated values. Next thing we want to find is the median. The median, remember, is all about finding the center of the data, finding that position. So for the median, these numbers are already put in order. 1, 2, 3, 4, 5. We have to find the position for the median. The position is 0.5 times n. So we do have to make sure we have this sum of the frequencies to get n. 0.5 times 100 is 50. Remember, if that comes out to be a whole number, it is between that number and the next one. So it's between the 50th and the 51st number. Well, where would that be in our list here? Well, we start at 1. There are 7 ones. So if you think of it as making a list here, there's 1, 2, 3, 4, 5, 6, 7 ones. That's the 7th number in the list. The 8th number in the list then is going to be the first 2. There's 12 of those. So if I listed out 12 2s, at that point here, after listing all the 2s, we would be at 19 because we had 7 1s and 12 2s. Well, then there's 41 3s. So we've already got 19 with the 1s and 2s. The 41 3s are going to take us up to 60. Well, we said the median here is between the 50th and 51st number. Well, since the 20th to the 60th numbers are all 3s, both the 50th and 51st numbers must be 3s. So the median is a 3. Now that can be a little bit confusing. And what we're doing is we're just looking at if we did list these all out. This would be the 1 through 7 would be the 7s. 8 through 19 would be the 2, or 1 through 7 would be the 1s. 8 through 19 would be the 2s. The 20th through the 60th would be the 3s. The 61st to the 91st would be the 4s. And the 92nd to the 100th would be the 5s. So the 50th and 51st must both be in the 3s. For the mode, well, the mode's pretty easy from here. Mode is which one appears most often. The 3s appear 41 times, so the mode is 3. There's 41 3s. I'm going to erase a little bit of this mess just so I can go back now. Range is pretty simple. Largest number is a 5, smallest number is a 1. So the range is simply 5 minus 1, or 4, the range of 4. Standard deviation. The standard deviation is a tough one. Remember, the first step in the standard deviation is to find the mean. So we've got that already done. Second step in the standard deviation is to subtract the mean from each. From each value. So up here in our table, what we're going to do is we're going to subtract that mean. It's going to be our number minus the mean. Now the number, the value is the 1, 2, 3, 4, not the frequency. So 1 minus 3.23 is a negative 2.23. 2 minus 3.23 is a negative 1.23. 3 minus 3.23 is a negative 0.23. 4 minus 3.23 is 0.77. And 5 minus 3.23 is 1.77. Now, when we were talking about doing this with single numbers, we said that you would add this column up and it should add up to 0. At this point, that may not necessarily be true, because remember, it's not each of these single numbers here. They're each appearing more than once. So we don't have all 100 of these listed out. If we listed out all 100 of these, it should add up to 0. Our next step, just like in any other standard deviation, the third step is to square each number. So we are going to square each of these. So negative 2.23 squared is 4.9729. I'm just going to put in 4.97. Negative 1.23 squared, 1.51. 0.23 squared, 0.05. 0.77 squared, 0.59. And 1.77 squared, 3.13. Now again, those are obviously rounded off to 2 decimal places. Now here's the extra step, because it's a frequency table. This 4.97 doesn't occur once, it occurs 7 times. The 1.51 doesn't occur once, it occurs 12 times, because there's 12 2's. 0.05 occurs 41 times, because there's 41 3's. So we've got to add an extra step in here, which is to multiply by the frequency. So up here, we're going to do the 4.97 times 7. It was 34.79. We're going to do the 1.51 times the frequency of 12 for the 2's. So that's 18.12. Do the 0.05 times the frequency of 41 for the 3's. 2.05. The 0.59 times 31. 18.29. And the 3.13 times 9. 28.17. So we have all those. Our step 4 then, remember this was an extra step in there. Our step 4 was to sum them up, to add them up, find the sum. So let's do this here. 34.79 plus 18.12 plus 2.05 plus 18.29 plus 28.17 gives us a total of 101.42. So we have a sum right now of 101.42. Nope, that one down there. That one. Nope, the one you just had. There you go. That's the one. So we get our sum of 101.42. Now that's all 100 of those added up because we weighted them. So then step 5 is to divide by n minus 1. Well, in this case, n equals 100, so we're going to divide by 99. So 101.42 divided by 99. 1.024. Now that would be the variance, as we noted in the last class. But to get the standard deviation, we have to do one more step, and that is the square root. So the square root of 1.024. So my calculator, second square root, second answer. 1.012 we're going to go with. So that is my standard deviation. So what that's saying is, on average, each of the values in this list are just over 1 away from the mean. So that is the mean and standard deviation found from a frequency table. Does anybody want me to go through and do a simple little example of another quick example of that? You guys are good? Okay. So our next step then is to go ahead and look at, go ahead. Using a frequency table and kind of tying it in with probabilities. So I want to do just a quick little introduction to probability. Probability talks about how likely it is that something will happen. Probability can be based off of a couple of different things, 3 different things. One is it can be based off of experience or history. For example, if we want to know what's the probability of a randomly selected student passing the course, we would base that probability off of the history. In the past, we've had 2,400 students take the class and this many passed, so we can use that to determine a probability. It can be determined from theory. If we have, in simple examples, the theory is probably the easiest way to do it. If we have things, especially if they are equally likely, that's a big term in statistics and probability. Equally likely means that there's the same chance that anything will happen. Like flipping a coin, it is equally likely to get a heads or a tails. So the probability for that can be based on theory. The theory is, in those cases, is the number of, based on the number of results, or what we call outcomes. It's the number of successful results over the total number of possible results. So rolling a dice, rolling a die. If I want to know what's the probability of rolling a 2, there's only 1 2 on a die, and there's 6 possible results, or 6 numbers. So it's a 1 out of 6, or a 0.1667 probability. And the third way that probabilities can be based is subjective. Now, subjective isn't necessarily just a flat-out guess. It's an educated guess. For example, most sporting events, when they set probabilities and stuff like that, they're going to look at the two teams and look at how they match up and look at their records, their histories. But at some point, somebody just has to come down to guessing that I feel this is the probability that this team is going to win, or these are the odds. And, odds are just a variation on probability of this team winning this game or going to the Super Bowl or whatever you're looking at. We're going to concentrate on theory in here because, well, and maybe just a little bit on history, because that's the easiest ones to work with. Subjective gets pretty complex in how they adjust those. In general, the biggest thing about subjective probabilities, they have to be open for adjustment. If you create a subjective probability and it seems to be leaning one way or another, you have to be able to adjust that to get it more towards the center. So anyway, let's look at the theoretical probability for a second. As we said, theoretical probability is the number of successful results divided by the total number of possible results. For example, let's say that I'm going to put 8 red and 12 blue marbles in a box. What is the probability? I'm going to use some notation here. What is the probability of drawing out a red marble? So that P with the red in parentheses is asking, what's the probability of reaching in and randomly selecting a red marble? Assuming that the marbles are the same size, same texture, that there is no way to distinguish between them without actually seeing the color. So I reach in and I pull out a random marble. The probability that it will be red, well, there are 8 red marbles in the box, and there's 8 plus 12 or 20 total marbles in the box. So that's a 0.4 probability. What's the probability of drawing out a blue marble? Well, there are 12 blue out of 20. That divides out to be 0.6. What I've created here is what we call a probability distribution. A probability distribution must have 2 big conditions. One, it must include all possibilities. If I'm only drawing out one marble, those are the only 2 possibilities, either red or blue. 2, the probabilities must add to exactly 1. 0.4 and 0.6 add up to exactly 1. Now there are some other minor things in there, and all probabilities must be greater than or equal to 0, and they must be less than or equal to 1. So you can't have any negative probabilities, and you can't have anything bigger than 1. I think it's common sense that you can't have negative probabilities. 0 is a probability of 0 is it's impossible. If I asked you what's the probability of drawing out a green marble here, it's 0 because there are no green marbles in the box. So there's no probability there. So a negative probability wouldn't make any sense. It can't be less than impossible. Okay. So that's our basic probabilities. Now what we're looking at here, of course, this is all the possibilities if we're only drawing one marble. There's a whole bunch of other possibilities we can get into if we're drawing 2 marbles or 3 marbles, and we're not going to discuss that quite yet. We may bring that up on Friday if there's a little extra time. But I want to look at now a probability distribution based not on theory but on history. And we're going to go back to that number of classes. Now I'm not going to use the same numbers that I did before. We are going to go, actually 0 I said we can't have in there. So we're going to go 1 through 5. And now instead of listing frequency, we're going to list probability. How likely is it that that will happen? So remember, each of these probabilities has to be greater than or equal to 0 and less than or equal to 1. So that to be between 0 and 1. And our total has to add up to 1 if these are all of the possibilities. Let's say there's a rule that you can't take more than 5 classes. So now let's do this. Let's say that the probability of having the randomly selected students only taking 1 class is 0.09. 2 classes, 0.12. 3 classes, we're going to go 0.41. 4 classes, 0.31. And 5 classes, oops, this should be 0.09. Let's make this 0.07. Then this will be 0.09 for 5 classes. So those are our probabilities. Now we're going to double check here. If we add this up, that does add to 1.00. So this is a valid probability distribution. So now I can ask questions like, what is the probability that a student will have at least 3 classes? Well, at least 3 would be 3, 4, or 5. So we would find ourselves adding up those probabilities. And that's going to add up to 0.81. So the probability that a randomly selected student would have at least 3 classes, 3, 4, or 5, is 0.81. If I know the probability that the randomly selected student would have less than 4 classes. Now, wording is very important here. Here I said at least 3 classes. So that would say 3, 4, or 5. The 3 is included. Here I did not say at most 4 classes. I'm going to write that down here. I said the probability that they had at most 4 classes. At most 4 classes would include the 4. The less than 4 classes does not include the 4 because 4 is not less than itself. So the probability that that randomly selected student has less than 4 classes is the 0.07 plus 0.12 plus 0.41, which adds up to 0.60 or 0.6. For the at most 4 classes, that's all those probabilities. So I'm just going to put down the 0.60 plus the probability for 4, 0.31. So that's 0.91 is that probability. Another way I could have found this, of course, I could have added all of those up like I did up here. 0.07 plus 0.12 plus 0.41, and then add the 0.31 to it. I just took a shortcut by taking a number I already knew included the first 3 and added the 0.31 to it, the probability for the 4. The other way I could have done that to quickly calculate it is I know that the whole distribution adds up to 1. So at most 4 classes, the only one that's not in there is the 5. So I could have just done 1 minus 0.09 is 0.91. So the probability of having at most 4 or less is another way I could have worded that, is 0.91 because it includes everything except the 5. So we just subtract the 5, the probability of 5, out of the whole probability of 100% or 1. So when we're looking at a system like this, it's actually fairly easy to find the probabilities, but we can then step on to something called an expected value. And an expected value is kind of like an average or a mean. What it does is it takes that probability table a distribution table. And we're going to basically find that, well, not basically, we're going to find the mean of it. So our first thing is going to be the number times, instead of the frequency, it's the number times the probability now. So 1 times 0.07 is 0.07. 2 times 0.12 is 0.24. 3 times 0.41 is 1.23. 4 times 0.30 is 1.24. And 5 times 0.09 is 0.45. And if we add all those up, we're going to get 3.23. You'll notice this right here. Now, I said I wasn't going to make them the same, but I actually did. These probabilities that I put in here are actually equal to the relative frequencies if I had just used the table I had up above. Remember, the relative frequencies, you're finding taking the number for each divided by the total. That's exactly how I made this table. Each of these is a relative frequency. 7 out of 100 became 0.07. 12 out of 100 became 0.12. So it makes sense that if the probability distribution is just a relative frequency table, it makes sense that our expected value, the mean of that probability distribution, is the same as the mean of our frequency table. And this is actually one other alternative way of finding the mean of a frequency table like this, is rather than multiplying it out and then dividing by the frequency, you could do the relative frequency and multiply each number by its relative frequency. So I want to go through an example here quick now, summing up what we've done so far today. So we're going to take a look here at an example of, let's say, look at number of cars owned by a household and frequency. So let's say we've got 0, 1, 2, and 3 are the different values of cars that we have in the house, in the households that we've surveyed. And so we have 8 households that report owning 0 cars. We have 18 that report owning 2 cars, or 1 car, I should say. Sorry, I'm adding these up as I go here. We have 21 that report owning 2 cars. And 3, I think that's going to work out, they report owning 3 cars in their household. So let's find the mean of this. Our first step in finding the mean, there's 2 ways we can go about it. We're going to go about it in both ways, just one right after the other. Our first way is going to be the number times the frequency. So 0 times 8 is 0. 1 times 18 is 18. 2 times 21 is 42. And 3 times 3 is 9. Then we're going to add those up. If we add these up first, we get 50. We add these up here, looks like we get 69. So our mean is 69 divided by 50, which is 1.38, I believe. Yep, 1.38 is our mean. Standard deviation. So let's do median while we're here. Median out of 50 so you do 0.5 times 50, so you do 25. So that's telling you it's between 25th and 26th item in the list. So if we come up here, you know, 0 to 8, or the first 1 to 8, I should say the first one to the 8th one are zeros. 8 plus 18 is 26, so the 9th through the 26th are 1s. Well, so it's between the 25th and 26th. So the median here is a 1, because the 1 goes from the 9th to the 26th. The mode, well, 2 is the one that's the most often, so 2 would be our mode. For standard deviation, let's do our number minus our mean. So we have 1.38 that we're going to subtract. 0 minus 1.38 is a negative 1.38. 1 minus 1.38 is a negative 0.38. 2 minus 1.38 is 0.62. And 3 minus the 1.38 is 1.62. Next step is to square them. Negative 1.38 squared. 1.90. We're just go to 2 decimal places again. 0.38 squared. 1.14. 0.62 squared. 0.38. And 1.62 squared, 2.62. And then each of these has to be multiplied by the frequency. So 1.9 times 8, 14.4. 18 here times the 0.14. It's 2.52. And 21 times the 0.38. 7.98. And the 3 times the 2.62. 7.86. So next step is to add those up. So 7.86 plus 7.98 plus 2.52 plus 14.4. 32.76. And we're going to divide by n minus 1, so we're going to divide by 49. Which would give us the variance, but we want the standard deviation, so we're going to square root that. Yes, 0.818, we're going to call it, is our standard deviation. Now, had we done this with a relative frequency, let's go to a new page. Let's find the relative frequency quick and see how it turns out. Our total here is still 50. So our relative frequency would be 8 divided by 50, 0.16. 18 divided by 50 is 0.36. 21 divided by 50 is 0.42. And 3 divided by 50 is 0.06. Those better add up to 100. Or 1, I should say. Now to find our mean, we're going to do the number times the relative frequency. Now remember that relative frequency is also a probability. What we have right here with those two columns is a probability distribution. It's using historical data. But anyway, 0 times 0.16 is 0. 1 times 0.36 is 0.36. 2 times 0.42 is 0.82. And 3 times 0.06 is 0.18, which adds up to 1.36. Did I do something wrong there? Oh well, it's not adding up to quite exactly the same, but it's really close. I may have done something wrong at some point. Oh well, anyway, you guys get the picture. Anyway, that's enough for today. That's everything I have for today. On Friday, we're going to talk more about probabilities, and we're going to talk about conditional probabilities and contingency tables, where we can compare two values at once and how their probabilities are interrelated. And then that will be it for this last unit. So again, Monday is our unit test. Next Wednesday, I will have, by the way, by the end of the day here, I hope to have posted that recording from our review of dosage calculations. So next week, Wednesday, I will have an opportunity to redo a test for dosage calculations for extra points. That is it for today, so you guys have a great day.